Welcome to the first session of the Demonstrating Implementation Excellence stream in the SNOMED CT Expo 2021. My name is Linda Bird and I'm the Implementation Support Lead at SNOMED International, so I'm very pleased to be moderating this session. Please use the discussion forum on your device to type your questions to the presenter, and then all questions will be answered at the end of the presentation. I'm now delighted to introduce Michael Lawley from CSIRO in Australia, who will be presenting on SNOMED CT support for OpenMRS via FHIR. Please go ahead, Michael.
Thank you, Linda, and welcome everybody. It's a pleasure to be able to talk to you today about this project that CSIRO did with SNOMED International. This work is in essence an extension of work we did back in 2019 to build a demonstration EHR interface to illustrate how to use modern terminology APIs to build a responsive and high quality user interface for SNOMED code selection. This tool has been used extensively by us, SNOMED International as well, and is always a great way to show what's possible with a FHIR terminology server in particular, but also just to give people a concrete idea of how simple it can be to build an interface for selecting SNOMED codes. So to take this to the next level, SNOMED International approached CSIRO again to do a follow-on activity focusing on demonstrating an EMR system with a real system. And what we selected was OpenMRS, which is a collaborative open source project to develop software for delivery of healthcare. It was primarily developed out of Africa for dealing with HIV and AIDS, but it was always envisaged to be a general purpose system and is used across Africa, and also in the Asia Pacific region, which gives us a particular interest in its use as well. So looking at the architecture of OpenMRS, we can see that it's built around this idea of a core platform and then a set of plugins or modules. And this provides extensive flexibility, but it also means that, especially combined with its age, began in 2004, there's a large number of overlapping modules providing related functionality using a variety of different software stacks. So things from the early Java UI classes through to Swing, and then a range of different additional technologies. But what we identified in the end was the HTML forms module as the best option for doing our integration work. We selected this because it's reasonably popular, reasonably widely used. It's very flexible. It uses native HTML plus additional built-in tags, but it's also easy to extend with additional new tags. And it gives you a cross-platform user interface. So by extending the HTML forms module or providing an extension to it, we get a cross-platform solution that can demonstrate the ideas that we want to get across. The next challenge we ran into was the internal model of OpenMRS. So OpenMRS adopts a concept-based model. This is not the terminology concept, but a sort of generic idea of a concept, so that everything in OpenMRS concept, everything is static. It has an ID, but given an ID, you don't know anything about what the type of this thing is. So you have to introspect or know in advance that the thing that is identified is a terminology code or a field in a record or an instance of a record or a patient, etc. So the level of abstraction is quite high, and it does make the code a little bit opaque at times. So OpenMRS is built around a core platform and then a set of plugins or modules. Now, because of this, and also because of the age of the architecture and the systems, as I said, began in 2004, there are a lot of modules and they overlap quite substantially in places in terms of capability, and they use a variety of different stacks, especially at the user interface end, from ancient Java UI things all the way through to more modern HTML. So what we had to do was identify the right way to extend OpenMRS, and what we settled on was the HTML forms module. We did this because it's a reasonably popular module. It's very flexible. It uses native HTML, so all the HTML tags for building forms. It has a set of its own extension tags that do OpenMRS specific things. Of course, it gives you a cross-platform solution, but additionally, it's possible to add new tags. And so this gives us a way to develop our own module with new tags with this terminology-specific capability. There are some other challenges that we faced when doing this, one of which is related to the underlying conceptual model of OpenMRS, where everything is a concept. This means everything is given an identifier. They are all static and pre-allocated, but that identifier tells you nothing about the type of the thing that it identifies. So it may be a terminology code, but it may be a field in a form. It may be the form itself. It may be an instance of a record. It may be a patient. You need to introspect or know in advance somehow what an identifier actually refers to. This means that technically it can be challenging to implement, but also when you're building forms themselves, you need to know what all these pre-allocated IDs are. So some things are a little bit opaque, but that is just the way that OpenMRS is. The other significant challenge is that terminology is treated in a fairly static way. So every code has to have a corresponding object in OpenMRS. This means it doesn't particularly scale well. If you are looking at just all the SNOMED codes, you're looking at 500,000 pre-allocated objects potentially. It doesn't have a good versioning story. So it really just assumes that you have a single version of any given piece of terminology. And it doesn't really deal well with the notion of subsets of terminology for different purposes. So these were challenges that we had to work around, and I'll talk a bit about how we resolved those later. So what we did was we built this new module called Terminology Search. It's open source, available in GitHub. You can see the URL there. And this adds one new tag to the HTML form module, or for use with the HTML form module. And you can see an example of it here on the screen. It uses the FHIR Terminology Services API. So really what we're leveraging is that runtime capability of that API. And the example we have here creates an input field. The input field is identified with the ID tag. There's an associated question. So every field has a corresponding question. So you see the question concept ID there. There's a concept class attribute that we have to specify. This is related to needing to know which of the categories or classes of codes a particular terminology code belongs to. So it's an internal OpenMRS classification process. The size field is just the size on the screen of the input field, and the label text provides an alternate label for display if you don't want to use the default label associated with the question concept. And then the last piece, of course, is the value set URI. So this is really the place where rubber hits the road. It's where we specify the set of concepts that are valid values to enter into this field. So under the hood, when this is used, as you type into an input field, you'll get a search happening. It'll be doing an expand call to the terminology API, expanding that value set and filtering it down to just the set of codes that match what you've typed. There's some additional properties, optional properties. You can see them documented here. I won't go through them all in detail, but the last two are I think, of interest. One is this prefetch all Boolean property. If you leave it out or set it to false, then you get a type ahead field. If you set it to true, and you should only do that if your value set is small, what you get is a drop-down control instead of a type ahead control. So this is suitable for small value sets where you really essentially want a pick list. And then the last property there, include designations. This affects the dynamic concept creation. And so just flagging that here, and then I'll talk a little bit more about it when we get to that part of the talk. So what does this look like in practice? Well, you can see here an example of the input field in action. There's the label that would have been specified, or perhaps this text came from the question concept itself, and then the type ahead input field here, and the set of matches that have come back. Now, this is particularly long set and not a good illustration of the user experience because the underlying value set is not particularly narrow, but it gives you a sense of getting back all the matches and the sort of dynamic nature of what's possible. And if you've played with the SNOMED UI demonstrator, it's exactly the same look and feel as you have there, but in a running system. So what happens when you actually select a concept? I said before that OpenMRS expects all the concepts to be predefined in the system. This plugin doesn't require that. What it does is dynamic concept creation. So when you select a concept for use in the field, the plugin interrogates OpenMRS to say, do you already know about this code? If it does, then the code goes into the record and everything's done. If the code's not known, then what happens is that the information that came back about that code in the expand request is used to create an object for that code on the fly. And so that's why we need the concept class attribute, because we need, when we create a concept, we have to put in the specify what class it falls into. In this example, it's a diagnosis class. And we can also pull back additional information at that point, such as its parent, so we can put it in the hierarchy within OpenMRS, so we can build out some additional content there, and also add in all the synonyms if that's required. And so that's what the include designations property was for. If that's specified as true, then all those synonyms will be available and they'll be populated into the concept at that time. Now, that may or may not be useful. It's not required for use of this plugin because the FHIR API is already searching across all synonyms. But if the concept is being used elsewhere in the tool in a different part, in a different module, then those synonyms might be useful for the driving the internal search algorithms. So with this module, what we do is we significantly improve the capabilities of OpenMRS with respect to terminology in general and SNOMED in particular. And that's because the API gives you access to the power of FHIR value sets, and in particular, all the implicit value sets that are defined for SNOMED. So this means any reference set can be directly accessed through the API. A set of codes that's characterized by a parent code and all its descendants, or in fact, any ECL expression. They can all be used directly as the value of that value set attribute in the form, and so you can do your binding very, very quickly and accurately. Of course, it's not just limited to SNOMED. You get access to the power of any FHIR value set, and so that includes other code systems, LOINC, ICD, CVX, etc. So with this one plugin, we really raise the bar in terms of what this the EHR platform can do with terminology. So what we have is we've provided an opportunity to develop a plugin module to enable a standards-based and more advanced implementation of terminology using both HL7 FHIR and SNOMED CT. So thank you for your attention. There are other great talks from both CSIRO presenters during the week and also from other Australian presenters. I'll quickly draw your attention to those here. Please don't miss them. And if you want to chat more, come and visit our booth. Otherwise, thank you for your attention.
Thank you very much, Michael, for your wonderful presentation. Could you all please give us one moment while we switch over from our pre-recorded content to our live session so that Michael can answer the questions you've submitted. And please note that this session will be available on the event platform for the next 3 months. Thank you. Hi, everyone. Welcome to the session. I've actually lost my audio at the moment, so I'm not sure if you can hear me or not. Michael, do you want to nod if you can hear me?
Yes, we can hear you.
So I'll just keep talking, but I can't hear you. So I don't see any questions that have come in during the speech, but thank you so much for a wonderful talk. Since there are no questions, I'll just ask you a couple if that's okay, and you'll have to let me know when you've finished. Firstly, what's the uptake been like for the OpenMRS to SNOMED service that you've created?
Yes, well, I think the issue we've had really has been one of timing. So we did this work in the middle of COVID hitting, and some of the primary candidate areas for uptake, Asia Pacific in particular, have just been slammed, and so we really haven't seen much traction in what we've done so far, which is unfortunate, but we will press on.
Thanks, Michael.
Somebody has raised.
Also, if someone wants to implement a system in OpenMRS and use your SNOMED connection service, what would you recommend that they do? How would they go about that?
So I guess the first thing is you need to be using the forms module to build your user interface. You need to design your forms. So this is just the normal process with OpenMRS. It has a completely dynamic user configurable data model. So you define your fields, you define your questions, and then you can, in the HTML form, connect those up to the data model, and using the new tag that we introduced, point that at your FHIR terminology server, reference the appropriate value set that has the concepts for that field, and you're done. It's really not that big a change from what you would normally do in building an HTML forms module.
Thanks, Michael. And apologies that I can't hear my audio at the moment, but do you have any last words to add?
Only
I see that there's a question coming on the audio as well. Ronald said, excellent work, will be great to use for our medical informatics training program, but no questions now. Thanks, Ronald. And Anna agrees, we need to tell people how to, raise a question.
how to use the system.
Thank you. Are there any other questions from the audience? Thanks, Ishmat, who has just congratulated Michael on a great presentation. Do you have anything to add, Michael, before we finish up? Please feel free to post some last minute questions, unless Michael has anything to add.
Just please reach out if you have any
I'll
questions.
just give you another
come and talk to me or anyone in the booth. We'll be happy to answer questions anytime. Yes, Ronald, there is a walkthrough on the GitHub, so that's really the first place to start is the GitHub. That's where all the documentation lives.
Major problem OpenMRS is trying to solve. Do you want to take that, Michael?
So I guess OpenMRS was originally built to provide a low-cost, i.e. open source solution for an electronic medical record system. So it was originally came as a response to dealing with HIV across Africa, and it's grown from there.
Thanks, Michael. Does anyone else have any questions? You can use the live Q&A at the bottom of your screen if you do. We'll just wait another couple of minutes in case anyone has any questions. Oh, Ronald's asked how to integrate in practice. Is there a walkthrough on GitHub? Oh,
Yes.
I think, have you answered that, Michael?
Yes, I did. Yeah.
Answered that one. Okay, sorry. Not having audio doesn't help. I'm so sorry. Is there anything you'd like to add before we finish up then, Michael?
I'd just like to congratulate you for persevering.
For my lack of audio. Anything you'd like to add, Michael, before we finish up?
No.
No. Are you happy to finish up there, Michael?
Yes.
Okay, wonderful. I'm so sorry for the lack of audio on my side, but thank you so much, everyone, for joining our first session at the SNOMED Expo. And I hope you really enjoy the week and all the other presentations that we have in store for you. And thank you so much, Michael. for a wonderful presentation. Goodbye. Enjoy your week at the Expo. Thank you. Bye.
Thank you.